Dear learners, it's my pleasure to welcome you for this lecture on frozen food packaging. Freezing is one of the convenient methods of preserving foods. It is the easiest, quickest, versatile method. Foods that are properly frozen maintain the original texture, color, flavor and nutrients than foods preserved by other methods. The final quality of the frozen food is determined by the condition of the food at the time of freezing. Unlike canning, freezing does not sterilize foods. It slows down chemical changes and simply retards the growth of microorganisms and then affects the quality or cause food spoilage. Packaging technology of frozen foods can be strategic importance to a company as it can be a key to competitive advantage in the food industry. This may be achieved by catering to the needs and wants of the end user, opening up new distribution channels, providing better quality of presentation, enabling lower cost, increasing margins, enhancing brand differentiation and improving logistic service to the consumers. The retail marketing of frozen foods began over a half century ago and it was successful. The rapid growth of sales reflects consumer satisfaction in the high quality of products, availability of the product throughout the year and convenience in product use. More frozen foods are sold each year because of consumer appreciation of product values and new products are introduced to swell the total sales. Objective of this lecture is to understand the theory and trends in frozen food packaging, decide the types and methods of packaging for different frozen foods. Let us first start with the time and temperature tolerance of frozen foods. The time and temperature will have an integrated effect on frozen foods. It affects the color, flavor and texture as well as their quality. The time temperature tolerance of the product is defined as the degree to which the individual products can tolerate the time and temperature effects. Quality assurance standards of a company must specify and control both the time and temperature factors so as to guarantee the product quality. Cost considerations are vital in developing the mandatory or voluntary quality assurance standards and regulations. Enforcing laws and policies are costly in view of the wide distribution of the products. Controlling vast number of products and variation in the stability of individual products is also costly. In order to retain the consumers, the frozen food industry makes utmost efforts of all segments to prevent conditions that could lead to the product deterioration and would cause consumer dissatisfaction so as to provide extremely high quality frozen products. Let us see few points about quality of frozen foods. The frozen foods quality depends mainly on the quality of the raw materials used and during the manufacturing stages of the product. In many cases, the failure to maintain the product temperature at appropriately low level in any stages of the cold chain, which includes transportation, storage, distribution and also during the display in the retail stores, may lead to product quality deterioration. Fault in inventory control would make the product to be retained for long periods in the cold chain and such failures in operation would lead to customer dissatisfaction and produce hazard to the entire industry. Stabilities in frozen varies from product to product and it depends on how fast they develop abnormal flavors and whether they discolor easily or not. Same type of frozen food from different lots may have different stabilities and it depends on many factors including the quality of raw material, processing techniques, product ingredients and packaging materials. Low storage temperatures can significantly increase the storage life of the product. Temperatures of -18 degrees Celsius or below is required. Normally, storage life is expected to exceed 6 months and above. What types of foods are commonly preserved for freezing? Water is a facilitator of biochemical deterioration of foods. Dry foods are much more stable than wet foods because any water remaining in them has low water activity. Freezing removes water from the food matrix by forcing ice crystal. Although the ice crystals remain in the food, the remaining water which is in contact with the food matrix becomes concentrated with solutes and its water activity becomes low. Freezing is therefore akin to drying, and this is rationale for preserving food by freezing. Most microorganisms cease functioning below the water activity of 0.7. Commonly, frozen foods are those which contain appreciable amounts of water. Living cells, biological materials in the natural state are able to hold typically 80% of water by mass on weight basis. Therefore, foods derived from them contain similar high proportions of water. This also applies to engineered foods such as ice cream, where water-ice mixture is required to impact texture. Now, we will see how to handle frozen foods. Exposure of frozen foods at high temperatures can be a serious factor contributing to quality loss. Short periods of exposure to high temperature are not serious unless it is often repeated, but continuous and prolonged exposure can cause damage leading to microbial hazards. However, for some highly sensitive food products, even a short duration exposure to temperatures in the range of 10 to minus 15 degree Fahrenheit will result in loss of product quality, which will only become visible after further storage. Migration of moisture from the product is due to temperature fluctuations, and it should be avoided because they will cause formation of ice crystals and produce partial dehydration of the product. Generally, the product temperature is considered to be more important than the air temperature because the change in air temperature for a short duration will not affect the temperature of the product significantly. The basic design of the refrigeration equipment used in the transportation of the frozen foods to remove heat load that may leak into the compartment of the container. The refrigeration capacity does not provide the space for removal of heat from the load. Therefore, when the products are loaded with the temperature warmer than 0 degree Fahrenheit, there is little or no opportunity for the temperature of the product to be reduced to the required level during transit. Likewise, display equipment in retail stores are not expected to remove significant heat from frozen food. Therefore, it is important to maintain the temperature of the frozen foods at 0 degree Fahrenheit or even colder when they are loaded for transportation or projected in retail cabinets. Shipping containers contain standard institutional and retail sized packages that warm up rapidly when exposed to elevated temperatures and slowly cool down when they are kept in the ordinary storage rooms. Time duration of the warming up and the cooling down will result in quality losses of the product even through the air temperature of the storage room is minus 18 degrees Celsius. Large sized products and bulk frozen food containers warm up much more slowly. Now, let us discuss about packaging concept. Generally, consumer trends and mindset will affect the growth of frozen food packaging market. The frozen food packaging film industry and its market requires improvement in mechanical performance, leading to adequate barrier properties and good advertising function for the rapid packaging and automation, providing pro-environmental argumentation. The industries are curious in developing differentiated films for smaller and easily openable packages that are low temperature resistant and also microwavable packaging, which enhance the branding philosophy. New design features will help in enhancing the branding. Overall performance will give additional benefits with good down causing flexibility. Food packaging skills requires innovative and economic solutions to provide excellent food quality and high package integrity. In new product promotions, package designs are significantly important. Let us discuss about theory of frozen food packaging. Packaging plays a key role in protecting the frozen product from contamination by external sources and from damage during its passage from the food producer to the consumer. The key functions of food package are protection, preservation and presentation. Protection is necessary to prevent the following: external biological contamination, dehydration caused by moisture loss and freeze burn, oxidation of lipids, flavors, colors and vitamins, loss or gain of aromas, and physical damage during storage and transport. Frozen food packaging materials must be able to withstand low temperatures of -25°C to -30°C. The materials used, besides being specifically for food, must be chemically inert, non-toxic and prevent the transfer of foreign odors or flavors. They must be stable, elastic, tear resistant and proof against water vapor and volatile substances. They must also offer protection against light, particularly UV rays. They should be adaptable to different aromatic packaging systems of an appropriate size and shape for a easy storing and distribution and ready for opening. Packages should be effective as thermal insulators to limit possible temperature fluctuations within the product. Different varieties of primary packagings are currently available, including plain and coated films, metallized and laminated plastic films, plastic trays with lids and thermoforms often contained in paperboard sleeves or cartons. The materials most commonly used for frozen food packaging include paperboard and molded pulp that have poor barrier properties but good structural resistance and provide protection against physical damage. Plastic materials with excellent moisture, oxidation and aroma barriers. Semi-rigid plastic containers that have good structural properties. Aluminum that is a total barrier to moisture, oxidation and aroma. The most commonly used plastic packaging materials are LDPE, HDPE and polypropylene. These are excellent moisture barriers but they have poor oxidation barrier properties. PVDC, PVC are excellent moisture, oxidation and aroma barriers. Ethylene vinyl alcohol, copolymer and polyamide with poor moisture barrier properties and excellent oxidation and aroma barrier properties. PET with good moisture, oxidation, aroma barrier and good heat resistance. The heat resistance is even greater in crystallized polyethylene terephthalate. We will see now about frozen food packaging trends. Mechanically improved packaging with increased pack line speed and seal integrity, automation of consistent and strong packaging materials, easy openable packaging and smaller packs, tougher and reclosable packaging in a bigger packs or multi-packs. Mono materials are less dominant over multi-material structures. Product integrity is highly important in frozen food packaging. Since very low temperatures inhibit microbial growth, frozen food products typically do not require additional preservatives when stored at temperatures of -9.5°C or less. Food safety is also highly important one. When food is frozen, residual moisture turns into ice which inhibits growth of most microbial species. Now about durability. Frozen food packaging must be able to withstand the rigors of machine filling, sealing, freezing and storage, transportation, thawing and often cooking. Let us look about microwavability. Packages intended to go from freezer to microwave must be engineered appropriately to ensure package integrity and product protection while assuring the film withstands the stress of the microwave process. Next is nutrition. The appropriate film structure for any product intended to be microwaved in flexible packaging depends on the nutrient content of the product. Last one is shelf life. Freezer burn occurs when ice crystals or other moisture on the surface of the product evaporates, leaving grayish white spots on the surface of the food. As evaporation occurs and freezer burn develops, oxidation can come in contact with the food, creating further deterioration of the food product. Proper packaging that retains moisture can help reduce freezer burn and extend product shelf life. Now, we will discuss about the packaging materials used for frozen foods. LDPE is one of the most common plastics used, providing good protection against moisture loss as a flexible film pouch or as a coating on paperboard. Heat resistant HDPE and PP film pouches are used for boil in bag or microwavable pouch. Heat resistant PET can be used to form trays or coated paperboard trays that are dual ovenable. Coating the LDPE or HDPE with PET or PVDC photopolymer increases the oxidation barrier properties. Irreversible dehydration will occur at the surface layer of the frozen meat unless it is packed vapor resistant and airtight material. Trays that are formed from foamed PS have a very low density but produce a rigid material. The skin tight PVDC film package is mandatory in case of poultry and its pieces are put into bags. Then they are transferred to a rotary vacuuming machine which packs the poultry product with clip closures and bag along with the neck trimming. When the bags are shrunk, then they form a second skin around the poultry. Then they are either frozen in brine or in a blast freezers. The function of the oxidation barrier is enough to prevent fats from becoming rancid and the water absorption is negligible. PVDC film and a various range of laminates with PE are the most common material used for packaging. PVDC is used in vacuum packaging mainly for packaging the frozen foods. It is a better alternative to glazing process and it eliminates moisture loss on initial freezing. The drip loss on thawing and weight loss on glazing is also eliminated. It reduces the labor and time needed for traditional glazing. The fish is able to retain its fresh characteristics by lightly vacuumed package along the entire distribution process. PET film packaging material is also used for fish products to be packed in a pillow pack style. The film is laminated with PE and this lamination of packaging material possesses barrier properties. It is puncture resistant over a wide range of temperatures and thus it gives protection to the product during transportation. On a large scale, majority of frozen fruits and vegetables are packaged in a plastic films such as deep freeze grades of PE. They are then made into a pillow type packs on a vertical form fill seal machines. LDPE are most commonly used as moisture barriers in vegetable packaging. Ethylene vinyl acetate bags provides mechanical resistance for large weights of product along with necessary moisture barrier. Good heat seal properties and the ability to remain flexible at freezer temperatures are enhanced by EVA bags. An enclosable feature on the package is often used so that the food content could be used whenever necessary. The important purpose of packaging is to preserve nutritive value, texture, flavor and color and to prevent the food from drying out. Labels on packages will provide information whether the product is suitable for freezer storage or not. A good packaging material is reliable to have the following characteristics: moisture resistant and moisture or vapor proof, designed to be used for the food products, that means food grade material, leak proof as well as durable, doesn't crack at low temperatures and are not brittle, resistant to grease or water and oil, protection to foods from off flavors, easy to fill, mark, seal and store. How to select packaging materials? Selection of packaging materials mainly depends on type and nature of the food to be frozen, personal preference of the company and the availability of the packaging material. Containers larger than 1/2 gallon are not used for freezing fruits and vegetables. Suitability of the packaging films with the material. Monofilms still dominate volume sold in the market. To replace these monofilms, the co-extruded films with tailor-made combinations delivering functional properties are developed. Co-extrusion technology facilitates the combination of the sealing layer with a strong core layer together so as to obtain the desired optical properties and printability in the surface layer of the packaging material. Laminated film structures with combinations of polymers provide high stiffness and optical properties and also barrier properties. Hard and rigid containers are commonly used for frozen foods. Hard and inflexible containers made up of Plastic, aluminum, heavily waxed cardboard and glass are suitable for all packs. Straight sides of the rigid containers are easy to remove frozen foods and they are often reusable. Glass jars are also used for frozen foods in limited manner. Regular glass jars cannot withstand the extremes in temperature and they are used for specific purpose. Narrow mouth glass jars are not used for freezing of liquid foods since expansion of the liquid could cause the glass jar to break at the neck. Cans are widely used for frozen food packaging. Shortening cans and coffee cans are good for packaging especially delicate foods. Generally, cans are lined with a food storage bag and then sealed with a lid and a freezer tape because they are not airtight. Baking dishes and ice cube trays are normally used in food freezing. Baking dishes are used in freezing, heating and serving. Dishes are covered with heavy aluminum foil taped with freezer tape to avoid any quality loss to the product. Ice cube trays are preferably best for freezing foods in small amounts. Food is frozen until it reaches a firm consistency and then it is transferred to a freezer bags. Flexible bags or wrapping bags are widely used in food freezing currently. They are sheets of moisture vapor resistant materials and heavy duty foil. Flexible packs are suitable for dried packed vegetables and fruits, especially meat, fish or poultry. These bags can also be used for liquid packs. A protective cardboard cotton is used to protect the bags from damage and tearing, hence makes stacking easier. Laminations are made up of various combinations of paper, metal foil and cellophane and are used as a protective overwrap. We will see the last part of this lecture now, steps in packaging. The foods and syrups are cooled before packing to speed up freezing and helps retain texture, natural color and flavor of food. Foods are packed in quantities that will be used at one time. Most of the foods require headspace for expansion as the food freezes. Asparagus and broccoli, tray-packed fruits, breads and bony pieces of meat are loosely packed and hence they do not need headspace. In order to cut down the amount of air in the package, food is tightly packed. Firmly press the bag moving forward to the top of the bag from the bottom to prevent the air from re-entering. Sealing is done with twisting and folding the bag and securing with string. Generally, good quality rubber band, strip of coated wire or other sealing device is used. Freezer tape is used for sealing the materials and adhesive remains effective at low temperature. Let us summarize the points so far discussed in the given lecture. Frozen food tends to maintain their color and flavor better than the foods preserved by any other conventional methods. Freezing retains vitamin values better than other conventional preservation process. Choosing an appropriate systems approach to packaging can yield significantly benefit other than just cost. The cost used in productive plant operations, handling, storage and transportation are cheaper, thus leading to total systems approach to packaging optimization. Packaging in vapor resistant and airtight material will avoid the irreversible dehydration of the frozen meat. Food packaging requires a systematic approach to the innovative solutions with high package integrity and economic value in nature. Packaging technology of frozen foods is crucial to a company as it determines the competitive advantages in the food industry. Thank you.